Hello, this is Priya, and in this video, I'll be teaching you about debugging tools and techniques. I wanted to go over this topic mainly as a refresher for those of us who have a coding background and could use a crash course about this important and essential topic. It can also serve as a guide for those of us who are new to coding. First, I'd like to go over how this topic relates to software engineering. As we learned in Module 2, maintenance is the most time-consuming lifecycle activity, more than requirements, analysis, design, and coding. Debugging happens to be a part of the maintenance lifecycle activity. As you can see in the top pie chart, 60% of total lifecycle costs are maintenance-related. Out of those maintenance-related costs, 17% are known as corrective maintenance costs, which is the maintenance subcategory that debugging falls under. Now I will go over some generic debugging tools. Everyone at some point has probably used print statements to debug their code before. An example of this can be seen in the screenshot on the bottom. Do not worry too much about reading everything on the screenshots for this slide. The point of these images are to illustrate what certain debugging tools look like in general. Print statements can help you debug your code by letting you print out the value of anything at any given point of the code, so that you can see what those values are and or if they match what you were expecting. Similarly, unit testing can be used to see if your code works as expected. If one of your tests fails, you can see where in the code it failed and you can go back and fix your mistakes. Lastly, you can use a debugger, which is probably the easiest way to debug your code. I'll go over this more in detail throughout the rest of the presentation. Accessing a debugger is simple. Many integrated development environments, or IDEs, have their own built-in debugger that you can use. If you are using C or a similar language, you can use GDB or GNU Debugger on the command line by installing it and compiling the program with debugging information, and then typing in GDB followed by the name of your program in the terminal. I will now go over some common debugger aspects that are essential to know and understand. These include breakpoints, step into, step over, step return, and backtrace. To simply define it, a breakpoint is a spot that you can mark in your code so that when you run it, the execution stops at that point. While stopped, you will be able to see the states of everything, including variables. In most IDEs, breakpoints can be created by double-clicking on the left margin of a line of code. In GDB, you would type GDB and then the executable name followed by a new line with the word break, and then the line number you want the breakpoint to be at. Now, let's step into what step into does. Step into steps inside into the first line of the method being called. Step into is used in situations where you want to closely inspect or debug the behavior of a particular method or function. When you use step into during debugging, you're essentially instructing the debugger to enter into the code of the method being called and execute it line by line, allowing you to observe how each line of code within that method behaves. Step over is also commonly used when debugging. Rather than diving deeper into the current line you are on, like step into, step over just simply executes the line that we are currently on and then proceeds to execute the next one. Step return executes the rest of the method and then returns to where it was called from. Step return is especially useful if you used step into previously and now want to go back to where you were before after stepping through that method. There is another method called step out, which is similar to step return, but unlike step return, doesn't execute the remaining lines of the current function. Instead, it jumps directly to the point where the current function was called. Often abbreviated as BT, backtrace provides a stack trace about the sequence of function calls that led to the current point of execution. There are a few other debugging commands that you may encounter while using the debugger. Resume continues the execution of the program until it hits another breakpoint. If we do not have any other breakpoints in the rest of our code, it will execute the remaining code until the end. Terminate stops the execution of a debug session. Now, we will go over a simple example of debugging using the Eclipse built-in debugger. This code is a simple addition calculator where the user can first input how many numbers they want to calculate the sum of, and then they can input the numbers themselves. However, as we can see from the screenshot, there is an exception being thrown that causes the code to not work as intended and not give us the result. Let's see if we can use the debugger to see exactly what is happening here. In the error message, we can see that there is a problem at line 18. Let's put a breakpoint at line 18. Now, when we click on the bug icon, our debug session will start. We should also look into our variables. We can see our variables by navigating to Window, and then Show View, and then Variables. Here, we can see how many numbers the user wanted to calculate the sum of, and also those specific numbers. Now that we are here, please pause the video and think about what our next step would be when debugging this code. If you thought about stepping into the code, that is a good choice because line 18 involved the calculate sum method, so we should step through that. Now that we are stepping through this method, we see that our initial sum is 1 in the first iteration of this loop, where we add all the numbers in the array that holds all user input numbers. Given that our user input was for 3 numbers, 1, 2, and 3, this seems correct, as when we add in the first number only, we get a total of 1. As expected, we now have a sum of 3, since the number 2 was added to our existing total of 1. I equals 1, which makes sense because it is our second round of adding numbers and we start at I equals 0. Now, we are adding in our last number, which is 3, giving us a total of 6. This is our correct result, so we should be done with the method at this point. However, when we step over again, we go through the loop another time, and we are not supposed to do this, obviously. I should not be 3 because that would mean we have 4 numbers and we don't. We are even getting an array index out of bounds exception because of this. This means there is a problem with our for loop. It is iterating too many times. As we can see from the code, this is because we let I be greater than or equal to array.length, where it's only supposed to be up to 1 less than the length, because we start at index 0. We can fix this code by removing the equal sign after the less than sign. Now that we have fixed the code using the help of the debugger, it works and is outputting the correct result. Thank you for listening to my presentation. I hope this made debugging clear for you.